Hello my friends. Alright, excellent. We already did the essentials with data preprocessing by importing the libraries and importing the dataset. And now I'd like us to particularly focus on this feature scaling that we're about to do. So I've already taught you feature scaling in the data preprocessing part, part 1, where indeed we implemented together this feature scaling tool at the very end, feature scaling, where we learned how to scale with standardization the training set and the test set separately. Okay, so that's what we did. Now we are in a slightly different situation in the sense that indeed we do not have a split of the data set between a training set and a test set. And that, I remind, is because we want to leverage the maximum data in order to learn the correlations between the position levels and the salaries. So the first thing is we will actually apply exceptionally feature scaling on the whole matrix of features X. Then the second important point and the second difference with what I taught you before in this same data preprocessing tools implementation is the fact that in this situation we only applied feature scaling to the features, right? We only applied feature scaling to xtrain and xtest, which are the features of respectively the training set and the test set. And we did not apply feature scaling to the dependent variable vector y. But why was that? Why didn't we apply here feature scaling to the dependent variable vector y? Well, that's because remember, the data set for our data preprocessing tools implementation was a data set where the dependent variable was taking values 0 or 1, right? We can scroll up to have a look again. Remember, these were the purchased decisions of this retail company, and that's the dependent variable taking the following values: 0 for the customer didn't buy the product, and 1, the customer bought the product. And therefore, since it took value 0 or 1, then we did not have to apply feature scaling here, because exactly same as the dummy variables here, the values 0 and 1 are already in the same range as the one resulting from applying feature scaling onto the features. All right? But now we are in a different situation. Indeed, this is our new dataset, position salaries, where the features are indeed the levels going from 1 to 10, and the dependent variable taking values from 45,000 to 1 million. And so now I have a question for you, and after answering this question you will know what to do in any feature scaling situation. So according to you, do we have to apply feature scaling to this dependent variable, the salary? And the answer is, well, yes. I'm sure you guessed that right. Indeed, we have to apply feature scaling because we don't want this feature, which takes values much lower than the values of the dependent variable, to be neglected by the SVR model. And that even if there is not an explicit equation, like in multiple linear regression, this is an explicit equation because y is explicitly resulting from a linear combination of the features. And for our SVR model, this is not the case. We have an implicit equation, but still, through this implicit equation, well, if the salary is way higher than the features, and here this is absolutely the case, well, accordingly, the feature might be neglected by the model. And actually, I of course tried to build this SVR model without applying feature scaling, and you can check that this absolutely doesn't work. Indeed, if we don't apply feature scaling for our SVR implementation and training on this dataset, well, you will see that the SVR model will not work at all. So we have to apply feature scaling here on both the feature, where the values go from 1 to 10, and the dependent variable taking values from 45,000 to 1 million. All right, and so now you know everything about feature scaling. You know what to do in any situation. You know that you don't apply feature scaling to some dummy variables resulting from one-hot encoding. You know that when a dependent variable takes binary values like 0 and 1, you don't have to apply feature scaling either because the values are already in the right range. You also know that when the dependent variable takes super high values with respect to the other features, then you have to apply feature scaling to put all the features and the dependent variable in the same range. And finally, you also know that whenever you want to split your dataset into the training set and the test set, well, you have to apply feature scaling after the split. All right, so now you know everything about feature scaling, and By the end of this implementation, you will also know something very important to do with feature scaling, but on the practical side, which will be the inverse transformation of feature scaling. When you scale your features or your dependent variable, at some point, to get the final prediction and to visualize the results, you need to inverse that feature scaling, inverse that transformation to go back to the original scale. And I will, of course, teach you how to do it so that we can not only get a very relevant prediction at the end in this step here, and also a super nice visualization where indeed we have the x-axis and the y-axis back in their original scale. These scales of the levels going from 1 to 10, and this scale of the salaries going from 45,000 to 1 million.